Okay, the topic of discussion is decision tree. And I told you yesterday that we will discuss one more example of decision tree. So let us see, this is a data set having record 48,000. That means there are 48,000 instances. There are 16 attributes, 16 features are there. And let us read some of them. Employment, whether he is self-employed or an employee of self-state government, or he is a private firm or private employee, economic activity. What is his education? Whether he completed bachelor's, higher secondary graduation, 11th, master's, 9th, some college education, and something like this. So, what is the level of education? How many years of education? Marital status? What is the type of job? What is the relation in family? Race, gender, hours he worked in a week, country, and wealth. Now, if you read these attributes, if you read these features, you will come to know that employment type, education period, marital status, job, relation, race, gender, hours worked in a week, and country. These are independent features. And your wealth, whether you are rich, whether you are poor, what kind of your wealth status is, that depends upon your employment, your education, your job type, your gender, how many hours you worked, like this, right? And so, employment, education, period of education, marital status, job, relation, race, gender, hours, country, these are treated as independent features. And wealth is treated as a dependent feature. Once again, as I told you yesterday, see here, except education period and hours worked, all are attribute type, all are characteristic type, all are qualitative type, categorical type. And that is why majority of the features are categorical, and therefore it is better to go for decision tree rather than any other classification tool. So we'll go for classification tool as a decision tree. Note that there are 40,000 records, 16 attributes. Let us proceed for next. Classification. It is a major data mining operation. Give one attribute, for example, wealth. Try to predict the value of new people's wealth by means of some of the other available attributes. Applies to categorical attribute. Okay. What can you do with a data set? The first step is hello. आले होते का? नाही, तुम्ही येऊ शकता तसं काय नाही. बरं बरं 10 वाजता या, मग काय हरकत नाही. चालेल, मी फोन करतो तुम्हाला. What we can do with this data? See, always it is the first step that we go for summarization of the data. The summarization may be in terms of frequency, maybe in terms of descriptive statistics, maybe in terms of some graphical visualization, something like this. So you can see here, this is the data visualization of gender. How many males and how many females are in 48,000 records? So you will see that the total is more because data is more than 48,000. So 16,192 and 32,650 are males. 16,192 are females and 32,650 are males. Histogram is also shown. Now, apart from these two figures, even if we forget 192 and 650, we will see that females are 16,000, males are 32,000. It means what? Males are twice than females. 16 females, 32 males. So among the 48,000, one female, two males. This is the ratio, 1 is to 2. Female is to male ratio is 1 is to 2. And it is obvious because economical activity is majoritarily conducted by males, right? That is what the picture is. Now, another thing is this is the distribution according to marital status. See here, diverse peoples are 66,633. Married apart from spouse. They are married, but they are living apart from their spouse. Only 37 are there. Married, 22,379. Married, spouse absent, 628. Never married, 16,117. Separated, 1,530. Widowed, 1,518. So these are the different marital status, and these are the different records, record size. Accordingly, the histogram is prepared. So, as I told you yesterday also, you must be able to plot this type of histograms. The software gives this, but we must know how to do this. If you see this, you will find that the majority records are of this type. You see here, 22,000 and 16,000, that means around 38,000. 38,000 are from married and never married group. The third category is diverse one, 6,633. So these three in all carries a sum of nearly 44,000. Remember this. Okay. What is the contingency table? It is a better name for histogram. Okay. Let us see this. A two-dimensional contingency table. See, this is two-dimensional contingency table. Why it is called two-dimensional contingency table? Because one dimension is age group, another dimension is wealth. And according to age group, according to wealth, you are classifying the record. So you will see that age group 10, poor peoples are 2,507, rich are only 3. Age group 20, poor are 11,262, rich are 743. So you can see this according to age group and according to wealth values, this data is classified, and that is why it is a two-way table. It is a two-way table called as two-dimensional contingency table. It is a two-dimensional contingency table along with histogram. See this and see this. It is a two-dimensional contingency table along with histogram. And remember that it is quite possible to plot it in Minitab also. In Minitab also you can see. Now, it's a very interesting to note. See here. If you see this part, and if you find the percentage, you will find that as age increases, poor peoples are shifting to rich peoples. Poor category is shifting to rich category. That is what observation is. So this is how you have to plot it, you have to conclude it, you have to put it in written form. This is another contingency table. Now it is expressed in terms of percentage. This is not in percentage, but now it is expressed in percentage. And if you see, you will see that this is the distribution of percentage people in terms of percentage. So what it means is in between 40 to 50 age group, there is a more rich peoples, and as your age increases, the wealth decreases because your economic activity goes slow down. In early age also, economic activity slow down, and so you can see it is like a normal curve, right? Let us see this. It is again another. It is again another two-dimensional contingency table. Now, what is this two-dimensional contingency table? You can see that one feature is marital status. You can see this marital status. You can see here job values. You can see here job values. 1, 2, 3. Sorry, this is 3, 4, 5, 6, 7. And see here, it is 1, 2, 3. Hmm. No, it is like this, that missing values are blue type. These are the missing values. Then administrative clerk are these. Craft repairs are these. Executive managers are these. Farming, fishing is this. Handlers and cleaners are these. Machine operator this. Other services are this. Private house services are this. Professional specialty is this. Protective services are this. Sales this. Technical support this. And transport moving is this. And this is the frequency. So all this total will add up to 48,000 plus. If you take the row totals and column totals and total of that, you will find that it is 48,000 and something like this. This is the histogram. This is the histogram, right? So this is the presentation. It is a bigger two-dimensional contingency table. Now, why we are showing is this contingency table is quite easy to read. It is quite easy to understand. But this contingency table is not that much easy to read, is not that much easy to understand. And that is why if we increase the level from two-dimensional to three-dimensional, it will become more complicated. From three-dimensional to four-dimensional, it will become more complicated. And complicated tables will never be easy to understand. So that is why we have to search for some another tool, and that demands what is called as decision tree. This is three-dimensional contingency table. So see, three-dimensional. This is age groups. This is poor or richer one. This is male or female. And as you increase the level, it will become very hard to look, hard to understand, hard to interpret. Okay. Okay. Now this is the time to think. Why would people want to look at contingency tables? How many two-dimensional contingency tables we can go for? How many three-dimensional contingency tables we can go for? With 100 attributes, how many three-dimensional tables are there? with 16 attributes, how many one-dimensional contingency tables are there? Let us try to answer all of them. With 16 attributes, there will be 16 contingency tables, one for each attribute. Among the 16 attributes, how many two-dimensional contingency tables are there? So it is like 16C2 and 16C2 will be 120. So there will be 120 contingency tables. How many three-dimensional contingency tables are there? It is 560 and so on. This is 560 with 16 attributes. But with 100 attributes, how many will be three-dimensional contingency table? It is something like 1,61,700. Now, simple contingency tables, even though sometimes they are easier, but so many count 560, 120. It is beyond summarization. It is beyond interpretation. It is very difficult to conclude from all these 120 tables. So that is why contingency table idea is not workable idea. Okay. So data mining. What is data mining? Data mining is all about automating the process of searching for patterns in the data. Which patterns are interesting? Which might be mere illusions? How many can they be exploited? Which might be mere illusion means it is something like dummy. It is something like imaginative. There may not be reality. Which patterns are interesting? That's what we all are looking at right now. And the answer will turn out to be the engine that drives the decision tree, deciding whether a pattern is interesting. Okay. See, this is very important. We'll use information theory. Yesterday, I have shown you information values, information index. More the information index, it is a more informative criteria. A very large topic originally used for comprehensing the signals, but more recently used for data mining. The topic of information gain will now be discussed, but you will find it in a separate Andrew handout. Okay. Searching for high information gains. Searching for high information gains. So let us see here. You will understand the what is called as information also. Given something, for example, wealth, you are trying to predict, it is easy to ask the computer to find which attribute has highest information gain for it. Wealth values are poor and rich. Okay. Wealth values are poor and rich. See, the relation is husband, not in family, other relative, own child, unmarried, wife. You will see the classification poor and rich. Poor and rich. So, H of wealth means it is an information gain. So, H of wealth is equal to 0.79384. How it comes? How it comes? It is the total of poor divided by total. Total of poor divided by total. That is wealth. Means it is like a percentage of poor people. It is like percentage of fraction of poor people. Okay. See, for the relation husband, 10,870 are poor, 8,846 are rich. And now, if you see the index of wealth given relation is equal to husband, it seems to be 0.992385. So we'll see its exact formula. Information gain is there. We'll see its exact formula. But this is what we have to use uh, for discussing about the decision tree. Learning decision tree. A decision tree is a structured of set of attributes to test in order to predict the output. To decide which attribute should be tested first, simply find one with the highest information gain. So we can start with highest information gain. Okay. Okay. So we will continue this lecture tomorrow, because now you have what is called as lecture of cyber security.